Good afternoon to everyone. Thanks for joining us this afternoon. Today I will talk about rubber process oils, especially ones with fairly low aromatic content and which are still suitable for plasticizing many rubber polymers from EPDM to natural rubber to polybutadiene rubber and even to SBR. I will start from describing a bit about the development of green rubber and tire oils, and then I will move on to discuss some challenges of the future supply in tire and rubber industries. Furthermore, I will also discuss and introduce results from recent compounding studies that we have done with low aromatic tire tread oils, and then moving on to EPDM plasticization and using the same oils in those compounds. And obviously, finally, I will conclude in the end. But before going into details of oils and oil manufacturing, I would like to introduce the company I work for. That's Nynäs. It's a Sweden-based company, but I'm coming from Finland. My background is in rubber industry. I have been with Finnish tire manufacturer for more than 10 years before joining Nynäs 2 years ago. At Nynäs, we think that we are a bit different from many other oil companies. If you think about the big ones, the Shells, the BPs, the Exxons, their main business is in fuel. Everything else is a minority for them. At Nynäs, our main business, or we have two main business units. That's the bitumen. That is to us a European business, and then the tire the naphthenic oils for tire and rubber industries, but also to many other industries, and that is a global business for us. Today we have 4 refineries. They are all located in Europe. Tire and rubber oils we produce mainly in Sweden and Germany. But on top of that, we have also naphthenic oil hubs, 3 of them, one in the US, one in Belgium in Antwerp, and then the Asian hub in Singapore. This is where we supply most of the customers in Southeast Asian region. And on top of that, we have 25 naphthenic oil depots in most countries where there's significant tire industry. So we are really and truly a global supplier of tire and rubber oils. Sorry. Very recently, only a couple of months ago, we opened up a new rubber compounding lab in our global technology center in Sweden. There we can make rubber compounds in a small scale. We have a 1.5 liter mixer together with, I would say, the most important equipment, machines and instruments to measure the rubber compound properties. So we can accelerate our own development for tire and rubber industries, but we can also support our customers in compounding, in mixing, trying to find the best conditions, best formulations to use our oils in our customers' recipes. Here I have also listed the most important devices we have in the lab. As said, 1.5 liter mixer, roll mill, curing press obviously, from muniviscometers, rheometers to tensile testers, durometers, and then dynamic testers. We can do, I would say, all the basic rubber performance analyses that are often needed. Okay, so that's about Nynäs. Then we move on to oil industry. A few years ago, we had a survey carried out when we looked at the size of oil markets and size of the so-called base oil market. That is also the basis for the rubber and tire oils. The size of that a couple of years ago was estimated to be 37 million metric tons. And oils often are divided into 5 groups. Tire and rubber industry use mainly oils from group 1 and group 5. In the latter, we have vegetable oils. We have a lot of other oils with a fairly small significance. And then we have naphthenic oils that are strong everywhere today, and especially in Americas, but more and more also today in Asia. In group 1, we have a lot of familiar names like aromatic oil DAE, like RAE, TRAE, TDAE, MES. These are kind of a side stream products of group 1 technology. The main product in that manufacturing process is engine oil. And because of the more and more difficult requirements coming from the car industry, car manufacturers, some of these group 1 refineries have already been shut down today, and that development will continue in the coming years. The development is slow. You will have these oils available next year. Also, you will have them 2022 and so on, but the development is clear. These refineries are being shut down. Many of them are replaced by group 2 and group 3 refineries, also capable of producing engine oils. But what rubber industry is suffering from is the lack of solvent power. We lose aromatic molecules during that change. We have already seen some disruptions on the market. Today they are still, I would say, local, only certain time of the year, not all the time and so on, but the trend is clear. In this region, as you know, aromatic oils are still in use in rubber industry. I have collected here some information about what's happened in replacement of aromatic oils in rubber industry. And as you know, or as you might know, Sweden and Denmark, they are often the starting point of whatever is happening from the point of environmental safety and health. So also this development started in Sweden. The government in Sweden started to look at aromatic oils in automotive tires. In 2002, they even proposed a ban for aromatic oils in car tires. A Swedish-based company, Gislaved, they were already producing winter tires using non-aromatic oil in the tread compound in 1997. And then Swedish government followed. Then 2003, Germany also took some steps. The Umweltbundesamt, they worked on strategies to create a ban for aromatic oils. This was obviously a base for the European regulation that took place 7 years later. 13 years ago, 2005, a Finnish-based company, Nokian Tires, were the first European manufacturer to ban completely aromatic oils. This is also the company where I have been with before joining Nunes. And then, as you know, 2010, the oil legislation, tire oil legislation, was implemented in Europe, banning marketing of tires containing aromatic oils. The same trend was seen in Brazil 6 years later, when Brazil implemented the tire regulation. Together with that, they implemented the tire oil legislation. So aromatic oils are banned in Brazil today, which affects the whole South American market. As you know, today they discuss that strongly in China. At the moment, there is no compulsory system, but many of the leading producers, especially tire producers in China, they have made the decision to move out completely from aromatic oils. Earlier today, we heard that in Thailand, you are discussing a tire regulation that might be implemented and be compulsory in about 4 or 5 years. Hopefully, it's accompanied with the tire oil legislation as well. This will happen sooner or later, and this is a very good way to implement, basically making the companies the last ones to change from aromatics to other oils. Companies in Americas, companies in Europe have done that already. As said, leading Chinese tire companies have done it, so the industry will follow. In the same study, when we looked at the market size of base oils, we also looked at the market size of tire and rubber oils. This chart is for the tire oils, and as you can see, approximately 50% of tire oils are consumed in Asia. I would expect that for industrial rubber oils, the figure is more or less similar. So this is where the industry is. So this is also where the work towards safer options should be done. In tire industry, as said, there have been a lot of alternatives available after the European ban of aromatic oils. Here I have listed the most common ones of them. And as you see, none of these oils are free of aromatic components. The so-called aromatic oil DAE, it contains typically 35 to 50% aromatic species, but most of the other ones, they have a fairly high content of aromatics as well. What has happened in the industry is the change of TG. As you can see, aromatic oil has a fairly high TG, minus 40 degrees C typically. Most of the tire oils used in today have a bit lower TG. Will it affect wet traction? Possibly. So that's one of the consequences of the change. Sorry. But why were aromatic oils banned? All the others contain aromatic groups as well. It's obviously because of the number of polycyclic molecules. In Europe, also in Brazil, oil producers follow the content of these 8 polycyclic aromatics. And as you know, in tire industry, for instance, the sum of these 8 molecules must not be higher than 10 ppm. Here I have plotted the sum of those molecules in aromatic oil. As you can see, it's more than 200 in the sample that we had tested in the past. For the so-called green oils, typically for RAE, that figure varies from 3 to 9, depends on the supplier. Very recently even, we've seen figures exceeding the 10. So if you are looking at RAE, please be careful with it. One supplier may be okay all the time, another one might not be that good. TDAE, naphthenic oils, they are typically in that range from 2 to 6. In Europe, European Union has a tendency of making these requirements more and more difficult all the time. So one day the limit might be something else instead of 10. But at the moment, I haven't heard of that kind of a discussion. Whenever we are developing tire oils, obviously we have to look at the rubber performance, especially the dynamic performance. All the tread compounders especially, they are looking at the dynamic performance of their rubber, how it behaves at different frequencies, different temperatures. And oil can really affect it. Last year at Tire Tech Expo in Germany, we presented about our tire test results. We had a Nunes tire testing program in which we compared 4 different green tire oils. We tested the tire performance using these different tire oils, and we were able to show that with the same traction on wet asphalt, it was a winter tire labeled somewhere between B and C, according to European labeling. We could reduce rolling resistance by 5% just by changing the tire oil. So oil can really affect the performance, especially the dynamic performance of the compound. What is happening today in many tire companies? Obviously, companies are trying to improve the ratings in the label, so label is really affecting the development. We carried out also an analysis looking at how rolling resistance had developed after the implementation of the European label. And the development had not been fast, in average. But at the same time, we could find several companies already producing these AA tires in Europe. The market share of them today is really small. But these companies, they have the tools in their drawer so that whenever they need to be implemented in in full power, they can do that. Also in Europe, we are discussing and hopefully soon implementing a regulation and especially labeling system for winter tires. That is also creating interest and obviously causing companies to work more on winter tire development. What kind of label we will have, what kind of testing we will have, there is not yet a common understanding about that. Hopefully one day we would also have a labeling system for mileage, like they have proposed in the US. But I would guess that Europe might be even earlier than US, who don't seem to be able of making any decisions about tire labeling. So what did we do at our research center? We developed oil with low aromatic content than before, but yet it had has high solvent power and also fairly high TG. The oil I'm using in the study is kind of a model. It's not available commercially yet, but it's only a question of, I would say, a few months. In any case, during 2018, we will introduce one or more this kind of oils with low aromatic content, but yet really high solvent power and yet really good dynamic properties in rubber compounds. We have already today completed a compounding study in functionalized SSBR carbon black. Silica study with the same polymer is almost done, and an EPDM study is underway. But basically, what are the expectations in these studies? To get same or even better traction than with existing oils in tire industry, get lower rolling resistance compared with TDAE, and then especially lower content of polycyclic aromatic molecules. We want to make the industry a safer place to work. Also, we are expecting a good compatibility with EPDM, even if aromatic content in this model oil is fairly high. But we have tools to work on that a bit to offer the industry a high viscosity oil for EPDM. And as said, it's a question of few months that we hopefully have something to report. Here I have selected some of the data from our studies, starting from the carbon black SSBR study. And I would like to highlight here the fact that even if there's a fairly strong, large difference in oil viscosity, the compound viscosities are the same. The one on the left is TDAE, the one in the middle is naphthenic black oil. Those are the two, I would say, most common oils in the industry at the moment. And then our low aromatic naphthenic oil having practically the same viscosity. Rheometer properties obviously we measured as well. I would say there are no worries in that respect. But moving on to mechanical properties, as you can see, the new oil provides same hardness, almost the same tensile properties as the existing oils on the market. But when we look at dynamic properties, as you remember, the TG of the new oil is higher than that of the other two oils. So also the compound TG is higher. To me, based on what I have learned in the past, this is an indication of improved wet traction. Many people obviously look at tangent delta at 0 degrees C when they estimate wet traction, but to me, TG of the compound is almost, I would say, is as good an indicator as tangent delta at 0. And on the right, we have plotted the dynamic performance. And as you can see, the low aromatic naphthenic oil provides at least the same performance as TDAE, almost on the level of naphthenic black oil in this study. Higher oil viscosity leading to same compound viscosity, no differences on rheometer. And then in this case, difference in compound TGs is 1 degree. Dynamic performance is exactly the same as with TDAE. And this is basically what the oil could look like You can guess which one is. Oh, sorry, I have written it there. But basically, the one on the right is the low aromatic oil, and the one on the left is TDAE, as many of you might recognize, especially the appearance on the edges of the bottle. Those were tire tread compounds, but same oil we will try in EPDM as well. And typically, as you might know, naphthenic oils in EPDM provide really good mechanical properties and especially low heat buildup. They have, I would say, higher solvent power than typical paraffinic oils in this application. So they also lead often to a bit faster mixing times, and then you might be able to use the same oil from EPDM to SBR, thanks to the good compatibility. In some previous conferences, we have introduced different EPDM compounds meant for automotive and other industries. And today, I'm focusing on the one in the middle, the automotive seal compound, show a hardness of 65. And I have highlighted some of the test results. I will just go quickly through it. But basically, with naphthenic oils, yeah, you can plasticize EPDM compounds and you can get, I would say, decent properties. I have highlighted our high molecular weight Nitex 840 high viscosity oil, as this is what we are comparing the new low aromatic oil with. High viscosity and still giving a really good mechanical performance, high tensile strength, high tear strength. But as said, you can use the same oil also with other polymers, so it's really versatile. What we have already completed with the new aromatic oil in EPDM, we carried out a compatibility study. We basically made cured rubber samples, we immersed those in oil, we kept them there for 3 weeks, and then we measured the changes in the dimensions, in the weight, in the hardness, and so on. And obviously we had a theory that the better the compatibility between the oil and the polymer, the larger is the change. And what we found in the test, especially when we compare the high viscosity EPDM oils, bright stocks that are typically used in the industry with viscosities of 400 centistokes or so, with our new low aromatic oil, the solubility is a lot higher. Here I have also Nitex 840 that is used to some extent in the industry, and you can see that our new low aromatic oil is even better than Nitex 840. The other three, they are low viscosity oils that in this particular test have higher solubility. So, to conclude, I hope I have showed you that naphthenic low aromatic rubber and tire oils can be used to make really good tire tread compounds, but probably also really good EPDM compounds. We expect the content of polycyclic aromatic hydrocarbons to be lower than in most oils used in these industries, in these products today. And then obviously this is one step towards more sustainable manufacturing. We have heard several other presentations during this exhibition and conference about how to be more sustainable, and this is one way. You have heard a lot about using vegetable oils, even bio-based oils in rubber industry. That time will come as well, but we need some, I would say, short-term solutions as well, also in terms of supply capability, in terms of cost efficiency. So hopefully this is interesting for you. And finally, I would like to thank my colleagues, Dr. Kamia Alavi, Mr. Patrick Salomonsson, Ms. Emma Öberg in Sweden, as well as our partners in the study, companies like Arlanxeo, Orion, RDC, Solvay, Azelis, and Lanxess. So many thanks for your attention.